video is going to be a review for chapter or module 12. So um, that's on network troubleshooting. So we're going to go ahead and get into it. Our first slide right here, we're just talking about our different types of network topologies. You have physical and logical, and then they choose to also break down logical into both IPv4 and IPv6. So this is pretty straightforward. It's nothing to get tripped up on. When we're talking about a physical topology, it's all about the physical things in the network. Can I touch it? Does it exist in physical space? So looking at our diagram right here, it's worried about the location of our devices, the cables running between them, the device names, all the physical things that have to do with the network. When we get to logical, it's all the things that talk about what's on top of the physical network. So this is similar to where we get down into module 13 and 14, and we talk about the fabric of a network with our logical stuff. So our addressing, our protocols that are running on top, that's where our logical topology comes into play. So it's pretty simple to just compare these two diagrams right here, and you can see the difference in what shows up on each kind of diagram. Then obviously with IPv6, we just get IPv6 addressing involved. This next slide is just showing different types of documentation you would see for different types of devices on the network. So first right here we have router documentation. So it just lists device model, description, location, iOS, and license. And then we have our interface, a description of what that interface connects to, the IPv4 and IPv6 address associated with it, and so on. And then the same thing just repeats for our LAN, which is obviously our switches. Nothing much different. I mean, we have ether channels and trunks right here since we're dealing with switches and VLANs, but it's pretty similar to our router documentation. Our end device documentation is where it differs a little bit. This is your PCs, your servers, anything that an end user is interacting with. It still has similar things that we have for the OS and MAC address and default gateway on there. So this next slide talks about a network baseline. Now, what is a network baseline? How does the network operate on an average day? What is typical for the network? Now, why do I want a network baseline, right? The network baseline is important in troubleshooting because it helps you identify anomalies. If I know, this server typically operates at this speed, has this much processing power, and it's not doing that, maybe that's where my problem's at. If I know this end user typically uses this much data in one day, but he's not using it now, maybe there's a problem here. So it can be useful not just troubleshooting, but obviously with that example I just used of like data exfiltration, it's also a useful blue team tactic when you get to network security to see any anomalies in the network as well. Now right here, I think it's just talking about how to actually create one of these kinds of topologies. So obviously first you want to determine what kind of data you want to collect, and that just goes back to what we were talking about up here with the difference between logical and physical topologies. You gotta obviously know what devices and ports on your network and determining a baseline. Now there's specific tools out there that could be used to develop a network baseline, like NetFlow devices, or it could be very simple. If you just want to get a baseline between two devices, you could even just use like a protocol analyzer like like Wireshark. Now right here, we're just going over a couple of our show commands that can be useful in helping us, create these topologies. Show version is going to give us our iOS information on our devices. When we get to show interfaces, we get our interface information. Show VLAN, a lot of this is logical once we start issuing our show commands on the devices. So we'll go ahead and get into some review right here. Which topology diagram displays IP addresses? Now that is logical. Remember, IP addresses are a logical thing that we apply on top of our devices. Our devices don't come with a physical thing that is an IP address. Which document could be referenced to identify the OS on a server? Now, a server, obviously that's one of our end devices, so we're going to be looking at end system documentation right here. Which three statements will a network baseline answer? All right, so let's look at some of our options right here. First up, we have how does the network perform during a normal or average day? That's a network baseline. How much did the network cost? That's not included. What are the network policies? That's not included. What part of the network is least used? Obviously, if we are looking at an average day, within that data, we can also see what is least used. And on top of that, we can also see what is most heavily used. And that's our 3 right there. True or false, a network baseline never ends and continually gathers information on a yearly basis. False. Will you acquire network baselines multiple times throughout a network's lifespan? Yes, but is it a thing that is consistently updated on a certain schedule? No, it is not. Which command could be used to get detailed information about directly connected Cisco neighbor devices? Obviously, that's where CDP, Cisco Discovery Protocol, comes into play. So we're going to pick show CDP neighbor right there. Let's see how we did. Awesome. Okay, so now we are talking about the troubleshooting process. So this table right here is something you guys are going to have to memorize. You'll get quizzed about this on the exam. Cisco likes to break down the troubleshooting process into 7 different parts: define, gather, analyze, eliminate, propose, test, and solve. So if we want to look at this if we want to apply it to a certain situation, let's say you're working a help desk ticket, right? You're gonna get a problem, so you're defining that problem at first. You're gonna gather information on there. You're gonna do research. You're gonna talk to the end user. You're gonna find out what's wrong. You're gonna analyze the information. You're gonna internalize it and try to figure out what it means. And then from there, you're gonna break down. Okay, it can be this. It cannot be this. It might be that. And then once you have a probable cause, that can give you your hypothesis. Then you test that hypothesis. That could be in a sandbox environment, so that you're not actually doing it on production equipment. And then obviously after you test it and it works, you can go implement that solution and solve the problem. Now, questioning end users, this is always the fun part. If you're asking me, it's more of a waste of time in most situations. It'll be productive for about 2 minutes, and then Tommy Joe wants to just talk about his divorce and how the kids are leaving him. So yes or no questions is something you normally want to avoid. Getting the user to talk more will point to what you want to find out more. Obviously, you can see right here, you don't want to avoid yes or no questions, but you also want to use open questions. Yes or no, you're just getting one response from the user, which that can help narrow things down at the start of having a conversation with an end user, but you want to get more detail out of them. Gathering information. So right here we're looking at our ping, trace route, and telnet commands as well as a couple other ones. Now, yes, these aren't our show commands from earlier, but you can use all these tools right here to help you troubleshoot. Ping, you're testing end-to-end IP connectivity, trace route. You're doing the same thing, but you can see where a packet is dropped off. Telnet, testing, management, connectivity, same thing with SSH, and then we have our other commands right here, which you guys know what those do as well. This diagram right here just shows where, issues will typically operate at with different devices on the network. Now right here, different troubleshooting methods or approaches, right? There are 7, if I can count on here, but you're normally going to use these 3 right here. You're going to use a bottom-up, top-down, or a divide-and-conquer approach. Now you can see, I'll just talk about those 3. You guys can read the other ones. Well, with a bottom-up, I'm starting at the bottom. I'm starting at the physical layer, and I'm going to work my troubleshooting process all the way up to the application. Obviously, that just reverses for a top-down approach. Then a divide-and-conquer is when you start somewhere in between, may that be the network, transport, or whatever layer that is not the top or the very bottom, and work your way at the same pace in opposite directions. Deciding when to use these is based on, like we were saying with the 7-step troubleshooting process at the start, what kind of hypothesis are you forming? Maybe you do think it's just a physical problem, so obviously you want to start at the end and work your way up if you already think it's going to be physical. Maybe I think it's an application level issue. Okay, I'll start at the top and work my way down. maybe I'm not sure. Maybe it's just easiest for me to start troubleshooting at the network layer or something like that. Or maybe I'm working in a team where it makes sense for us to split our resources up like that. That's where you want to use something like divide and conquer. This table right here just breaks down what I was just talking about on trying to decide when to use those different approaches. All right, let's get into our review. Which option lists the 3 troubleshooting stages in the correct order? So obviously we want to start with gather symptoms, so we're going to start right here. We want to gather symptoms, isolate the problem, and implement corrective action. That looks right to me. We'll pick that one. In which step of the 7-step troubleshooting process would you create a rollback plan identifying how to quickly reverse a solution? Testing your hypothesis, that's when you want to do that, right? It's when you start to implement, you'll be able to better resolve a way to back out of whatever you're going to implement. All right, number 3, which are recommendations to be used when communicating with a user? Always be considerate, always listen carefully, and speak at a technical level that they can understand. All those sound right to me. During the gathering information step, which command would display the configured protocols and the global and interface specific status of any configured layer 3 protocol? That's going to be our show protocols command. What is the highest OSI layer that should be considered when troubleshooting routers and layer 3 switches? That's going to be layer 4. Now, yeah, you may say, why doesn't that stop at layer 3? Because we still have certain protocols that are operating at both layer 3 and 4, like TCP and UDP. Which structured troubleshooting method should be used when a cabling problem is suspected? Now, like I was just saying, maybe you suspect it's a physical issue, so that's when you want to start at the physical layer and work from a bottom-up approach. Which structured troubleshooting method should be used when a software-oriented problem occurs? Obviously, software, we're dealing with an application-level issue. That's a top-down approach, so we'll go ahead and pick that. And there we go. All right, let's get into some troubleshooting tools here. Now, what kinds of software troubleshooting tools do we have? We have NMS tools. These can be devices we have around the network, whether it be like an SNMP server or something like that, something that is used to manage the network and is doing some kind of monitoring, logging, or configuration. Knowledge bases. These can be anything on the internet, honestly. That's obviously a knowledge base, or a lot of times organizations will have an internal knowledge management libraries with documentation that can be helpful with figuring out problems on the network. Then you have baselining tools. Obviously, it goes back to what we were talking about earlier, those tools that you're using to develop a network baseline. This slide right here just talks about protocol analyzers, but you guys should be familiar with what Wireshark looks like. Hardware troubleshooting tools. We have digital multimeters. This is going to test the electrical output of a cable. Well, not necessarily a cable, but when you want to deal with like electricity and you want to talk about voltage and amps and stuff like that, that's when you're going to use a multimeter. Cable testers can be used to detect broken wires and other types of cable faults. When you talk about a cable analyzer, though, that's used to actually test and certify copper and fiber cables. Portable network analyzers. A lot of times you'll see these tools implemented in one, whether it be a cable tester, analyzer, and portable network analyzer. When I'm trying to troubleshoot that Ethernet cable that is connected up to the switch, it can give me other information, whether it be like the VLAN is connected to and stuff like that. Network analysis modules, these are actual physical modules that are placed on the network itself that are used to help troubleshooting with like various information that can be displayed in a dashboard like you're seeing right here. Syslog, we've talked about this before. There's a reason, you have a show log command that is syslog that pops up in the router itself. That is your first step in troubleshooting from a device normally. It can usually point you in the right direction as to what's going wrong, whether it be, failed authentication, Maybe a packet is dropped, something like that can point you in the right direction. All right, let's go ahead and get to the review right here. Which of these is an online network device vendor resource that can be used as a source of information? Like we were just talking about online resources of information, that's when we want to talk about our knowledge bases. Which tool is used to investigate packet content while flowing through the network? That's where Wireshark comes into play. That's a protocol analyzer. Which hardware troubleshooting tool is a multifunctional handheld device used to test and certify copper and fiber cables for different services and standards? That's our cable analyzer. Remember the difference between our analyzer and our tester. Our tester is not actually certifying, it's just showing us where the faults are at. A cable analyzer will actually certify that cable, saying it's 100% for us. Cisco IOS log messages fall into one of 8 levels, which syslog level is used to log the high severity level. That's 0, 7 being the least serious, 0 being the most serious. Let's go ahead and check that. Awesome. Symptoms and causes of network problems. So it looks like these slides right here are just going to break down kind of what we've been talking about already with a possible problems you're going to see at different layers. So right here we're talking about our physical layer troubleshooting, types of symptoms you may see that pop up and probable causes that those could be. So let's give an example right here. Let's say I have a multi-blade switch, and for some reason only four of those 6 blades are operational, right? I would look at my console log, and that could point me to something that's power related. Let's say the 2 power supplies I have in that multi-blade switch aren't operating at 100% to be able to feed power to all those blades, and that's why only 4 of the 6 are operating, or maybe one of them failed. That would be an example of our physical layer troubleshooting right there. Data link layer, remember, think MAC addresses, think STP over here. That's some of the problems you're going to see, but you guys can read about that right here. Network layer troubleshooting. This is where our routing tables and neighbor relationships come into play. Think ping can trace out when you're trying to troubleshoot at this level. ACLs, this is always the fun part. Trying to figure out whether an ACL is the issue. A lot of times a log of some sort is going to be able to help you in that regard. But normally it does break down to some kind of misconfiguration. Not often is a ACL. I lost my train of thought. We'll keep going. Transport layer. This is where we get into DCP, DNS, and SNMP, and those tunneling and encryption protocols. Point-to-point tunneling protocol, GRE. Talking about those things at this level. Application level troubleshooting, that's where all these protocols come into play. But also just try to think of the application layer as anything that the end user is interacting with. All right. Which OSI layer are you troubleshooting when the cause of network transmission errors is due to late collisions, short frames, and jabber? That's going to be physical, right? What could be causing late collisions, short frames, or jabber? Normally that's some kind of interference, could be a faulty cable of some sort, but all that boils down to a physical problem. Which OSI layer are you troubleshooting when investigating a spanning tree loop? Remember, I just talked about it earlier in this section right here. When you're thinking about data link, think STP, think MAC addresses, all those layer 2 operations. Which OSI layer are you troubleshooting when investigating a routing protocol loop? Routing protocol, remember, layer 3, our network layer. Which OSI layer are you troubleshooting when investigating an extended ACL related problem? That's our transport layer. Which OSI layer are you troubleshooting when investigating a DNS related problem? Remember, DNS is one of those application layer protocols, if you remember the table we just looked at. Which iOS command can be used to test if other network protocols are working? That's going to be telnet. I don't know if they talked about this one or not. Obviously, when you look at ping and trace route, That's using your ICMP packets. That's testing one protocol. But when we talk about Telnet, I can use that to connect to multiple different ports to test different services and protocols. Let's go ahead and check that. Awesome. Now this 12.5 section right here, we'll go through it quickly since there's no review for it. This is just a culmination of what we kind of been talking about. When you're troubleshooting connectivity, a lot of the times you are going to be troubleshooting IP connectivity, end-to-end connectivity, end-to-end internet connectivity, right? And it starts with just working your way up, whether you're taking a top down or bottom up or some kind of split approach or one of the other ones. You start verifying the physical layer. Look at something layer 2 like duplex matches. Verify your addressing at that layer 3. Just keep working your way up, right? Now, keep in mind with like this troubleshooting chapter, troubleshooting can be as hard as you make it, right? A lot of the times your gut is going to be pointing you in the right direction. You're all very smart, and troubleshooting comes down to applying everything you know, right? Once you've worked with something long enough, you can kind of figure out what the problem will be. I mean, obviously, at your guys' level, it's easy to figure out, okay, maybe this is a cable problem. But, obviously, when you get into larger enterprise networks, you start having, radius servers come into play, and it's harder to figure out these kinds of authentication issues and stuff. But, you know, this chapter is really teaching you guys those approaches to make and what to think about when you're troubleshooting. So just remember those top-down approaches, bottom up, and so on, and the 7-step approach that you need to take when you're troubleshooting, and you really can't go wrong. All right? I think that's it for chapter 12 then. Let me know if you guys have any questions.